is timing. While load flow is used, expansion, state estimation, contingency analysis, stability analysis, etc. May I get one confirmation from you? Are you really in my class? Is my board is visible to you?
Yes, sir. It is visible, sir.
It is little bit of blur, sir. Will you please dictate it, sir?
Is my board is visible to you?
So
Sir,
will you
it is
please
visible,
dictate it,
but
sir?
it is blurred, sir. Hello, sir.
Is board is visible? Somebody please reply to me. Am I audible? First thing. Am I audible?
Yes, audible.
Okay. Anybody in the class please reply to me. Okay. Am I audible? And board is also visible. Fine. So many of you are not replying. What I should guess? Are you active or not?
So
Are
will you
you
please
active
dictate
or
it, sir?
not? Board is visible. Okay, fine. Thank you. Thank you. Okay. So many of you are keeping passive. So make some active so that will be comfortable to me. So I'll get back. Load flow. Basically, we know the definition. Load flow study is one of the fundamental studies performed on the given power system to know how exactly the power is flowing on the transmission line from the generation to the distribution point of view. So when I say a power system is a interconnection of complex network by generator, transmission line, protection, we call them as a switch gear, and variety of loads and distribution. To make their objective that satisfactory operation of that system, the power system is equipped with all such requirements and functioning such that some economics, some technology is combined such that such an operation is highly profitable for the corporation. Therefore, when the corporation is invested so much of money in generation by generator, purchasing them, investing, operating, and making it, and distribution agency and transmission agency working for the other side, then how to plan properly, whether the current generation is appropriate, current transmission mechanism is correct, current switchgears which you have provided are adequate and they are able to respond to me and all. I should understand. For all such understanding, what is very basic? The very basic is to know the current state of health of power system. How is that generated power is pumped into the grid, and grid means nothing but transmission mechanism transmitting that to the end user. So which transmission line is burdened, which transmission line is lightly loaded, which is their generator in fully loaded condition, etc. Whatever so-called things which you would like to know should be taken into care. For that, load flow is a basic study which measures active power flow, reactive power flow, calculation of bus voltages and power factors of the vector or phase angles of which P, Q, V and delta. The determination of these quantities of a given power system itself is a load flow study. When I am able to find out these values pertaining to a particular type of bus, if it is a generator bus, what kind of calculation I should do to know the health and to perform further analysis. If it is a load bus, how I should do. If it is a voltage controlled bus, like an we can say the compensating devices are installed over there, or how reactive power is managed like that. If it is a slack or reference bus, how calculations are performed at slack bus, etc. need to be known. Once we perform all these things, we will have a set of information with which good decision can be taken, whether the current system is adequate to the current load. The loads are increasing gradually over a year or over a day to next. Whether this system right now installed is able to cope up with those changing loads. Do we need to install additional generators? If the transmission mechanism is appropriate for that transmission, or switchgears which are provided are very suitable for the current problem, type of problem, able to protect the system. Like that, proper calculation, proper study of the system from the perspective of security, reliability, and at the overall, whether system is profitable on this regard, technically and commercially. So in that regard, the load flow study becomes very necessary. Like diagnosing a patient in the first report, the expert doctor or the specialist will diagnose the illness, failure, lack by having a report available to him. On that first report, the diagnosis which is the report results what were obtained, the diagnosis of lack will be taken. Same way, this serves as a basic study on which lot of calculations, lot of other analysis are based upon. The first thing is load flow study is no doubt calculation of P, Q, V and delta. This pertain to study of these things only: active power, reactive power, voltage of a bus and phase angle delta. When we obtain them, what all these are used? These are used to understand planning and designing of the power system. Right now you have a system, or you would like to set up a new power system for a particular locality. How do you understand? How do you purchase the component? How many generators you need to install? What is the resource available? How many types of loads you have there? What is the length of your transmission mechanism? Its configuration, capacity, probable interconnection, what you would do. All these things you must know. For the planning and designing and configuring them to work for your requirement, we require basic study called as load flow. You might ask me, without having a system, how can you analyze? Yes, you are absolutely right. You have a lot of simulation software. You have a lot of simulation software in which you can estimate, you can design, analyze and conclude yourself whether this system is going to be in place, profitable or going to work for you or not. Therefore, the computational method, simulation software will come to your use. In that regard, this planning and designing and testing it on pre-work becomes very necessary. Unless I am going to become a profitable, able to meet the changing load, how can I say my system is perfect, secured and is reliable? So I must have some measures, some corrections in my approach. That's why planning, designing, it requires a load flow. Then future expansion. What do you mean by this? Right now you have a particular power system with a set of generator, transmission mechanism, protection, control, very state-of-art equipment installed. Whether this system will be perfect, able to meet the loads of next year, next but one, next and the next and another decade. You just imagine and predict. Do the current generators or generation capacity is able to cope up my next 5 years, next 10 years demand or not? Challenges of upcoming system or not? At that time, you must look forward for future planning. That's correct. Future expansion. If I want to perform, do my system has an ability to cope up for the expansion, what I should do? So this study, this implementation, what you would like to do, requires some primitive information. That primitive information is taken from load flow only. Hence, load flow is very necessary. It is a basic study on the given power system. A power engineer must keep ready with which. It is just like in the first report of a system. This is the health of the system from which any analysis from a different perspective can be performed and taken information from that. So therefore, it is necessary for future expansion also. Having seen lack in resource. Simply investing on generator doesn't work. You must see what is the resource available, what is the future perspective of that, is it really advisable to go next or not. All these things you can perform having the study performed and data available with you. And state estimation. The state estimation is a process of estimating the current health or a situation of the power system. I always compare the power system with a patient in ICU. When we have a patient with a supporting equipment, medication under the supervision of an expert, they keep on providing medicine, they keep on estimating the good health of the patient, what is expected, what is happening, how parameters are monitored on the monitors or equipment provided. On those observation data available, the prescription and next state of improvement or next corrections what should be done are taken care. Like that, state estimation is a process estimating the unknown variables, bus voltages, power angles, losses, and active power, reactive power flow in a state estimation control process. They are estimated by alternative methods. Once I start predicting base value, keep finding the best fit value of that, keep predicting the next best fit value of that by iterative processes. Iterative loop is configured. The best fit values are kept on estimating the best one, and next best one like that. That kind of state estimation. Is the system secure? Is it the next state is best or current is best? Or the upcoming state may be best? Like that, the variable best suited value for the current situation. Any current situation, maybe right now at this clock time, the value of V1 is best. I am sure that this V1 is not best for the next moment of time. Maybe the different loads are playing over there. Need not be good for next day same time. Like that, the variables what play currently, the best fit value of that variables, we need to estimate and use them in the control so that your controlling process becomes sophisticated. For that, we have a special study called as state estimation is a process. Lot of statistical processes are used in doing this, in which variables are estimated for their best fit value. So, for that state estimation process, we require basically load flow. Then, contingency analysis. Contingency analysis on a given power system is an process. I should see list on the given power system possible tracks, failure, mishappenings, what may occur, what not. List them one down the other, one down the other, one down the other, like a big list. Once you will see a big list, which are the possible tracks, possible failures, possible unexpected instances or events what would occur. List them and analyze the cause of each, effect of each, correction and control for each. Nothing but you have to have an exhaustive list of unwanted happenings on the power system. Instances or events what would get triggered on the power system, threaten the power system operation. You should list them and you should analyze one by one on the merit of their severity. Most severe among the big list you prepared is given as rank number 1. Rank number 1 means it is the most severe, very critical situation. System is going to collapse. Like that, severity index is assigned to that. And down the line, the next lesser severe, lesser, and the last least significant in the list. It means to say, prepare a possible list of possible problems or effects and analyze it. For that analysis, contingency is unexpected event or instant happening on the power system whose remedial must be kept. If this occurs, what is my remedy? If seventh contingency arises, what is my remedy for that? So these remedial measures must be kept readily in the CADA, Supervisory Control and Data Acquisition in the Energy Control Center. The energy operator we call as dispatcher. Computer control, the operator, energy engineer who is operating the power system, keeps the fault observed on the screen. He tried to rectify, he tried to control. For him, remedial measures are required. We keep them readily available as a contingency. Contingency is an unexpected event occurring on the power system whose analysis on the basis of severity by giving a rank must be performed, kept ready. And that should be scrutinized every moment. The severeness of the situation, like if I compare the same with the health of a patient having a heart problem, maybe respiratory problem, maybe liver or other associated problem in the ICU. Right now, patient is suffering from multi-disorder, which is most severe right now to save his life. That's called most severe. That's called critical contingency number one. How doctor treat it. The same way, the power system need to be compared. The most severe event, what would occur, should be given a priority, should not occur. Control that by control actions such that it will be prohibited or prolonged further. Next severe event, next one. For that, a computer programs are written, computer algorithms are run, and remedial measures must be taken. In that calculation, contingency analysis is very necessary for checking the security of the power system. Is the system is secured? Insecure, secured. When it is secured, it must have ability to counteract on every such instances what would occur. Like that, contingency analysis is one of the important requirements. In the further discussion, we will be doing it in the few, I think in the second part, we will be doing it. So let us say contingency is an unexpected event occurring on the power system and threatening the system to lose security. Such a study need to be performed to protect the system from such occurrences. For that computational requirement, we require basic things from load flow only. The next is stability analysis. As we are very much aware, stability of the power system is an ability to be in operating state which is normal even after experiencing minor or a major fault which definitely threaten the power system to lose its synchronism. Therefore, stability with the perspective of frequency oscillation, stability with respect to voltage instability, maybe a short or maybe a very long term. However, is that inability of the system is expressed. So therefore, the study of ability to be intact in serving the requirement even after experiencing certain difficulties, we consider it as stability of the system. To analyze that, you require a pre-information. How would I say I am stable? Unless I have been tested at certain checkpoint 1, checkpoint 2, checkpoint 3, I am passing through as I am stable. Like that, stability analysis must be performed on the given power system. It should pass those checkpoints. Then I could say system is going to remain intact in service even after experiencing so-called disturbances. So therefore, this study requires a lot of information. That again comes from load flow. I would otherwise say load flow is the basic study performed on the given power system to keep other analysis live. If you do not perform load flow study, other analysis, what one would do, become quite difficult. Roundabout route you have to follow. That's all. So this serves as a basic requirement for that. So I would say, when I said a basic theoretical aspect of which, so we require mathematical equation for that also. So we need to have mathematical proofs for that. Two basic equations, active power equation, reactive power equation. They are the two basic equations. We call them as network equation or load flow equation formulation. From those two equations, solving it repeatedly as per the technique chosen makes the process valid. So in the next class, I would definitely be going for two basic equations which are useful to analyze the load flow study are active power equation PI reactive power equation QI, PI, QI. So P and Q, active power, reactive power equations are repeatedly solved at each bus by type 1, type 2, type 3, etc. So no matter in the next class, maybe tomorrow's class, Vinod sir class, I know English. So I will just pick up this thing and I will begin with the load flow classification of buses and the particular load flow solution by Gauss-Seidel method. Okay. So I study one need to know. For that, we require basic formulation. The basic formulations require standard equation. You get back to the interaction what we have done in formation of system admittance bus by inspection method and singular transformation method, where the mathematical representation of the power system interconnection was brought into a mathematical term, where we put them as the bus of current, a vectorial representation of I1, I2, I3, I4, so many bus currents. Suppose n bus system, you had n currents were possible. Then voltages of each bus may be in the form of capital E1, E2, E3 or capital V1, V2, V3, together called it as bus voltage. So we had a vector of bus voltage. Then we had system admittance in the form of primitive elemental data got transformed into Y bus of a system, admittance bus. So there is a difference between primitive admittance and admittance bus of a system. So admittance bus of a system is a true representation of interconnection of the system by the consideration. Therefore, when I have that n equation, if I view the n bus system, n algebraic equations of bus currents I1, I2, I3, IK, IP, IQ, IN, etc., I can split it up and I can write them. It means to say n independent equation I can write, I can put them in the compact form as a matrix. That's what the first line says. I bus is nothing but a vectorial representation, a matrix of column vector. The first element in the column is I1, below which I2, I3, I4, I5, last be IN. Like that we have n current of a n bus system. Likewise, at the extreme right side, V bus we have bus voltage vector, which is bus voltage 1, V1, V2, V3, Vk, Vp, Vq, Vn, etc. Then with which we are multiplying a bus, system admittance bus, which is having on whose diagonal the diagonal elements like Y11. The second element in the second row, second column, Y22. The third row, third column, I am moving diagonally, 3, 3, 4, 4, 5, 5, and moving down to the extreme right corner, n cross n, y, n, n. It means if I have n elements in that system, n buses, it is going to represent you n cross n matrix. You might ask me, suppose if I do singular transformation method, if I obtain y bus by inspection method, how would it matter? Definitely it matters. Because we have seen in inspection method, the admittance bus of a system will be of real-time system size n cross n only. If there are 100 buses, 100 cross 100 matrix I am going to get. If it is singular transformation method followed for your reduction, reference bus being one of the reference or a ground as a reference, minus 1, the total number I should consider. So this expression which I have here, I bus equal to Y bus into V bus, take care that reference is taken out. So that number of elements in the Y bus will be n cross n, like that. I would otherwise say a vector of current is equal to matrix of that system in the form of Y bus with the product of that as a column vector bus voltages V1, V2, Vn, like that. This is a general representation from which if I consider any possible current I may be one of the entity in the 1 to n possibility. Then that matrix, if I expand, surely I am going to have n equations. Those n equations will compact the matrix form. If I expand them, I should get n equations. So in that way, let us consider only one sample expression which is ith bus. That's called II. The capital I refers current, small I refers bus number. At bus number I, what is the bus current injected? Where all it will flow? If I have a bus current I1 injected from the bus 1, where all it will flow outward? We have I1 to 2, I1 to 3, I1 to 4, like that. There could be a path for current to flow. In that regard, if I have this matrix form of representation, I bus equal to Y bus matrix into V bus vector, of that possibilities, I take only one element, ith possibility. Then if I expand only that equation, what will be the expression I am going to get? That element, I have other side. Y bus will have its elements in the form of summation of Yij. Yij refers to the bus from which I am starting computation I to the rest of the buses 1 to 2, 3, 4, 5, 6, 7, 11, like that. J keep on incrementing. Then all those values, if I take a product with respect to voltage, this is nothing but the n algebraic equation which I have put in the short form, where I becomes 1 to n. You can look into right side. For all n, for all I equal to 1 to n, this expression is valid. Capital I, ith possibility, I equal to summation of all the products of admittance with voltage. So which is J changing. For any value I, when I is 1, J is 1 to n. When I is 2, J is again 1 to n. If I have that product, I can have n equations. Nothing but I'll be back to the first equation in the form of matrix, and I can put them in the compact manner. So when I want to have a case study, only ith bus only I want to observe. From that above generalized matrix form of representation, ith possibility is II equal to sum of all the products of admittance Yij into Vj. You may ask me, how do you get Yij and Vj? Just look the Y bus representation. What is Y bus representation? Y11 is the diagonal element. Y12 is the first row, second element. Y13 may be first row, third element. If you just expand first row, you will get number of admittances in the row-wise representation. Then I have second row, Y22 in the diagonal. Before that, Y21, Y22, Y23, Y24, 25, 26, 2k, 2n, like that. In the second row, third row, fourth row, respective nth row. So we have n rows in the matrix, as well n columns in the matrix of Y bus. That particular one row you are considering, which row? Row number I. And column is shifted. When J is 1, ith row, J column, column number 1. Column number J equal to 2. You are moving laterally right side. It means to say the matrix Y bus is taken from Y bus, ith row only taken. In the row number I, you have several elements. So those elements are represented as capital Y, I, J, where I is respectively the one which are considering. J is incremented, J equal to 1. That ith row, first column, with the V1. With the J is 1, Vj is 1. When ith row, J is 2, second column, Y, I, 2 into V2. Like that, V3, V4, V5, all the n possibilities, if you multiply and get them added, you will come to know a KCL application. It's called KCL. The bus current at bus 1, suppose I is 1, injected at bus 1, where all it will flow? 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to n. The right hand side, you are summing up all the outgoing currents from that bus. In that way, this expression stands as current at bus I. It is Yij, Vj, for all the j 1 to n, sum of these products, summation j 1 to n, Yij, Vj is nothing but the current at ith bus. I may be anything like 1, 2, 3, 4, 5. You can see for all I equal to this. So this equation becomes very fundamental equation for me to proceed further. I have to take bus number 2, bus number 5, bus number 7 in the power system. Any bus I arbitrarily I am considering over here. When this ith bus is considered, look at the complex power. At bus I, VI may be the voltage, I may be the current. What is that SI, complex power situation at that bus? Look at the equation. SI is equal to VI, I conjugate. Like complex power equal to VI conjugate reference is taken. So I become my arbitrary observation. Nothing but bus number I is my focus point. Hence it becomes SI equal to VI. Product with I conjugate. You might ask me why you are taking conjugate. The conjugate is taken here to represent the complex power is a set of active and reactive power. When I separate them, the term with a cosine terms becomes active power. The term when I split it becomes sinusoidal terms with a J operator or a complex operator that naturally represents reactive power. Therefore, this complex power is nothing but active power and reactive power together. Hence, VI conjugate concept splits the power into active and reactive power in a very specific manner. Hence, it is referred. Then, in that regard, suppose ith bus is my point of observation. At ith bus, what is the complex power? You can look into that VI and represent the current of ith bus from the previous expression. So, I will be replacing II conjugate from the summation of product. So, sum of all the Yij into Vj for j equal to 1 to n and product with that Vi and take conjugate. So, if I take this conjugate and product of Vi, I will be replacing II basically. When I take a product and look into the particular observation, suppose what is Vi? Voltage of a ith bus in the system. So, what is the nature of the voltage over there? Voltage will be a complex term. Voltage is a vector with a magnitude V and an angle, the possible phase angle. What is the vector Vi? What is the angle? Let's say delta I. Like that, we have n voltages, delta 1, delta 2, delta k, delta p, and delta n may be the angles associated with that vector from its reference point. Likewise, let us accept arbitrarily a voltage at the bus which I am considering ith possess magnitude Vi and angle delta I. Then it is in the polar form Vi magnitude and angle delta I. And how we can split in terms of cosine and sine terms using Euler's identity? It is put as V cos theta plus J V sin theta concept. You would see that Vi outside the bracket magnitude, inside the bracket angle delta I is split using Euler's identity as cos delta I plus J sin delta I. If I had Vi angle minus delta I would have had minus J sin there. If I have plus delta I plus J sin. If I had a minus delta I minus J sin delta. Only the second term, the J operated complex term will have negative term. Hence, Vi delta I, if I consider, I could write Vi in this way. And as well see the next term, delta Ij. What is delta Ij? It is the angular difference between the vector of Vi, Vj. If I have number of buses in a system, V1, V2, V3, V4 may be the magnitude. Similarly, delta 1, delta 2, delta 3 may be the angles associated with the respective vector V1, V2, V3, etc. Then when I write delta Ij, it is the change in angle or angular difference between bus I, voltage V and angle delta I, and bus J, Vj and whose angle delta J. Then delta Ij is called as double subscript notation. Whenever I write any value, delta Ij refers to angular difference between the first subscript I delta I minus the second one J delta J. If I write delta PQ, the delta P minus delta Q. So this way, double subscript notation is to be understood because we will be referring it very soon. In this regard, the first vector Vi refers as Vi outside the bracket cos delta I plus j sin delta I for a bus I. Then delta Ij similarly refers to a bus connected to I to the j having angular differences delta I and delta j, respectively voltage if I speak Vj and some angle with a delta j. So, and if it is a beginning, then we must know what are I will be doing next. What is next I will be doing. For the load flow study, there are four important points: the active power, reactive power, voltage magnitude, and phase angle. Is the theta or delta over there. These are the four quantities which I will be trying to find out missing out of them. Suppose it is a generator bus. At that bus, out of these four quantities, V, theta, P, Q, whatever I am pronouncing here, two of the quantities will be known to you, two more are unknown to you. Finding out those unknown is the task of load flow study for generator bus. For a load bus, load when I say active power demand, reactive power demand is known to me. PQ are known to me, V and delta are unknown to me. To find out V delta or V theta is the task of load flow. Like that, I would like to project you V, theta, PQ are the four important terminologies which I will be using throughout the load flow study, whichever is the method I am using. Among those four quantities, respective to a case study which I will be taken, two of them will be given to you, two of them will be unknown to you. The unknowns need to be measured or identified. To get those unknowns, the procedure must be outlined using numerical solutions like Gauss-Seidel, Newton-Raphson, or any other allied fast decoupled techniques, etc. So, I am just projecting over here number of unknowns and which unknowns you need to identify. The upcoming session I will be looking forward. Next, once I know the complex power situation at any bus I, Vi conjugate concept I can utilize, I can represent in this way. Once I forward, when I have a bus I and bus J, two buses are connected by a transmission element. Let's say impedance is there with that, Z. When I want to represent the system in terms of admittance form, 1 by Z becomes admittance for me as a capital Y. When I have a bus I and J connected by a transmission line, it becomes very necessary for me to represent terminology like capital YIJ. It represents element between I and J. It is a elemental representation. There is a connectivity between bus I and J like YIJ. Is equal to what? G and B. What are these things? When I represent impedance, naturally I represent impedance by resistance part of the impedance and reactance part of the impedance. Like example, inductive R plus JXL when I represent, it becomes a Z. Impedance of an inductive branch is R plus JXL. Then what is that? Admittance of that 1 by R, 1 by Z if I write it. How do I write it? 1 divided by R plus JXL. I want to take that denominator to the numerator. I will rationalize it by complex conjugate multiplication. I will convert it with a calculation. It means I will be able to get admittance form of that in the complex notation having real term and J operated term. My conclusion over here is when I have an impedance, first term non-J refers to real term. The term which is with the J refers to reactive or a complex. Similar to that, in admittance notation, we will be having real and imaginary terms. The first term is G is called as the conductance of the admittance total. Conductance, and the second term is susceptance. It may be capacitive susceptance or inductive susceptance. Quite sure, transmission lines are inductive in nature. It must be inductive susceptance. How do you get this? If you take a Z, a value of Z 10 plus J 15. Take in the calculator 1 by 15 plus j 10, something like that. Take the answer. You'll come to know the total value gets reflected to the numerator when you are working in the complex mode. That first term, which is called non-j, represents conductance part of your admittance. The second term, which is associated with a j, with a minus or with a plus, so that term is called as susceptance. So in this case, I am trying to highlight the first equation, admittance between two buses I and j be yij, which is represented as gij, conductance part of the connected element, plus j times the complex value like your inductive or capacitive reactance, it becomes susceptance between I and j. This is a standard representation of admittance. No matter, you need not remember this. It's just if you know the impedance, 1 by impedance works definitely in this form. Try to know non-j, j terms, that's enough. Non-j becomes real term, conductance, j opposite term becomes the reactance, nothing but susceptance part of the admittance. Then, having known this, in the previous slide, complex power was just discussed. VI conjugate concept. There we used VI and we used the concept of II from the previous explanation. Then similarly, admittance between I and j is focused in this slide. Then Ij, Yij, and the representation of entire work in the form of yes, I is equal to sum of the products Vi magnitude, Vj magnitude with the cos delta Ij plus j sin delta Ij, and you can see that Yij conjugate became minus j dij. The first line, in this first line we have Yij, but here you have conjugate of this. The reactance term is plus, here it is minus, it's called the conjugate. How do you get conjugate? You go back over here, you'll come to know what is complex conjugate here. Vi, Ii conjugate. You can see this. There is a term here. Vi is here, Vj is here, Yij is here, over which conjugate is there. Can you see this conjugate? So, Vi is the magnitude, Vi, and Vj is the magnitude, Yij is the admittance whose conjugate is taken over here. Then Vi is represented as Vi cos delta I plus j sin delta I. Similarly, what is Vj? Vj is also voltage like Vi, which is Vj cos delta j plus j sin delta j. Nothing but like this Vi, Vj is also having a representation. One Vi representation in the complex form, Vj in the complex form, Yij in the complex form is used over here. Can you see this? Vi, this term, Vj, this term. You might ask me, where is delta I cos and sine? Where is delta j cos and sine? That is called mixed over here. How it is mixed? When I have two polar complex quantities multiplied. V1 angle delta 1, V2 delta 2. How do we do it? Product of magnitude, sum of angles comes there in a polar form. The same logic is used here. Here I have product of V1 with Vi with Vj with the conjugate. Nothing but this magnitude need to be taken conjugate. Hence, I will be having delta I for Vi, delta j for Vj. Hence, this has come here. I took here delta I minus delta j. What is the purpose of this one? When I have two voltages Vi, Vj to be operated on a multiplication, Vi is having plus delta I, Vj is having conjugate of that, nothing but minus delta j. Then delta I minus delta j is natural for me. What it represents? Delta Ij. Delta Ij refers to angular difference between ith value and j value. Delta I minus delta j, whose cosine and sine is taken here. Can you see this here? Product of Vi, product with Vj, and those cos and sine of delta I and delta j became cos delta Ij plus j sin delta Ij into the admittance conjugate. Conjugate of admittance became only the reactive term becomes negative. Now my task is sum of all such terms. Summation is here because we just turn back and see there is a summation block. Sum of all such products should be taken. to compute complex power. What is complex power situation at any bus? Net power what is available at any bus is the complex power flowing from that bus to remaining buses. If I take a KCL approach, incoming and outgoing approach called as a power invariance in broader terms. Power inflow power must be equal to sum of the outflow power into the transmission mechanism. That's what I am doing here. SI is the complex power injection at bus I, where it should go. It should flow into the transmission grid. That's what we are trying to sum up here. SI is the complex power at bus I. It has to flow in the transmission mechanism through elements Yij, where J is 1, 2, 3, 4, like summation block, split it. When I make this term, there is a complex multiplication again. Vi is a magnitude, Vj is a magnitude, cos delta Ij plus j sin delta Ij, product with another complex rectangular quantity. When I have these two products, surely I will be having j terms, non-j terms. So my next task is to take a product of cos delta Ij plus j sin delta Ij with Gij minus jBij. If I have these four terms, non-j, j, non-j, j, surely I will be having like this term. Can you see this equation? This term into SI, a complex power inclusive of active and reactive power, which I am writing. Non-j terms become active power. The term with j becomes reactive power, which if I split these terms, take a product of these two and take a grand product with this and write like this way as only real and imaginary part separately. I will say real term of this product stand as Pi. Pi becomes active power situation at bus I. Now this stand as standard equation for me, active power at bus I, Pi. Pi is cal, whatever I will say, calculated injection or calculated power at ith bus, which is only the non-j. You can see here, summation j1 to n as usual, Vi is as usual, Vj is also as usual. What about this product? You can see cos delta Ij, when I take a product with Gij, it is non-j, so it is Gij cos delta Ij. When I take cos delta Ij, product with jBij, it becomes j operated. Therefore, it becomes a reactive term. So this I'll split. Then I'll take second term, j sin delta Ij with the product of Gij. J comes out there. It's a reactive. When I take j sin delta Ij with minus jBij, j square becomes minus 1. J square becomes minus 1. There is already minus 1 here. Hence it becomes Bij sin delta Ij without complex operator. You can see here. Hence, active power will have non-j operated term as summation j1 to n product of magnitude Vi, Vj. The first term Gij cos delta Ij plus Bij sin delta Ij. The remaining two terms of the four, 1, 2, 3, 4. When I take a product of these, I'll have four terms. Two have come here, non-j. The remaining two are with j. They will appear here. Therefore, the imaginary part of this equation, Qi refers to j1 to n summation, same as Vi, Vj. Now look into this. It is Gij sin delta Ij minus Bij cos delta. You might ask me, how could you do it immediately? No matter, it's just a simple one step which is not written here. What would you have done? Take a product of A plus IB, X minus JY. Take a product of this. You will have four terms here. Those four terms you take a product with external Vi, Vj with sum. You will have two terms over here, two terms over here. This is how, these are the two standard equations in terms of Pi and Qi for the load flow study analysis. This is one way of representation. Now onwards, I would otherwise say the power situation, active power at any bus is Vi, Vj, bracket, Gij cos delta ij plus bij sin delta ij, sum of all such j equal to 1 to n. If I speak this, it is the active power from bus 1, suppose I is 1, flowing to 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to n, etc. You are taking at the right hand side. Through what? Through a transmission section having conductance Gij, having susceptance Bij. Similar to this, what is the reactive power of your complex power? Qi. Qi at bus number 1 has to flow outward from bus 1 to rest of the buses, which is taken as summation J1 to n product voltage magnitude of the bus from where power flow starts to the bus where power flow ends, Vj, Vi to Vj, where J is 1, J is 2, J is 3. Each time, those many terms, suppose you have elements in the system, you have 100 elements. J can have 1 to 100, definitely. V can be 1, J can be 1, 2, 3, 4, 500. You will have 100 such sum added 1 plus, next plus, next plus, like terms in the expression. So, that number of elements means destination buses J. That many products you are able to take with the Vi. Likewise, I is one of the bus. I may be one of the bus from n available. So, I can have I equal to 1 P1 P1 Q1 calculation. I equal to 2 P2 Q2 calculation. Likewise, I can be n. Similarly, J can be 1 to n. So, this is to represent a grand equation which would help us to compute active and reactive power situation at any bus I. This is one way of representation in terms of rectangular form of representation. Can you see over here? Gij, Bij, one is with non-J, second is with J. Nothing but when the word J is pronounced, it is a rectangular form of representation. Other way we can do by polar representation, where angle and magnitude appear. Can you see over here? As admittance Yij is also equal to Yij magnitude and angle theta ij. Suppose you look at the first heading here, Yij equal to Gij plus Jbij. J witness you as a rectangular. I don't want to use rectangle. I want to write a polar. What do you do? G square plus B square, which is become under the root a magnitude, which is your capital Yij in the magnitude form. Double bar between which we have Yij. Nothing but it is a square Gij square plus J gone, Bij square under the root become magnitude. An angle bracket theta ij. What is theta ij? Tan inverse of reactive divided by non-reactive. Tan inverse of Bij divided by Gij become theta ij. Nothing but by having calculator with you, you can convert rectangular to polar, having its magnitude and angle associated. If I have elemental representation, which is admittance in the form of polar, how I should do it? Look into this. Again, we can write complex power Si, which we began Vi angle delta I. Can you see here? Angle delta I, Vi angle delta I represent polar form of a vector representation. Vi is the magnitude, delta I is its associated angle. Sum of such with Yij. What is this Yij? Admittance of the element between I and J, angle theta ij with a conjugate. Because of conjugate over there, Si equal to Vi conjugate, we got it complement. Hence it is minus of theta ij. You can see here. Similarly, we had a voltage of jth bus, Vj, magnitude minus J, because we had a conjugate of vector. So all the representation, Vi with the delta I in polar, Yij with the theta ij, polar, Vj with the delta j, polar. I have a polar magnitude. If I take a product, can you see over there? Take a product and make them with cosine and sine approach. When I have this angle bracket, angle and theta, cos of the magnitude plus j sine of magnitude. Likewise, the first part of the product Si with the cosine term of which works as Pi. Active power from this complex power SI is VI as usual. Angle is taken in type summation J1 to N Yij as usual. Vj brought here and product of magnitude and sum of angles should go in polar product. Then I will be having the first part of the active term is cosine operated, reactive term is sine operated. Can you see over here? Cos of, look to the angle, delta I is plus, delta j is minus, theta ij is minus. The same thing is put here. Cos of minus theta ij plus delta I minus delta j. From this, what is the modification being done? Take minus out of this cosine term. What will happen? This becomes cos of minus theta ij minus delta I plus delta j. Now cos of minus angle become automatically cos of the angle. Now you will see the last equation. Active power situation at any bus I is sum of J1 to N, VI, Vj, Yij, cosine of theta ij minus delta I plus delta j. This is valid for all the I 1, 2, 3, 4, N. So from bus number 1, P1 you can calculate. Bus number 2, P2 you can calculate. Bus number 3, P3 you can calculate. Like this, 1, 2, 3, 4, like this, all the bus active power you can calculate. This equation is very much similar to the first equation which you find here. Pi equal to summation J1 to N Vi Vj Gij cos delta Ij plus Bij sin delta Ij. Whatever the equation you find here, it is exactly same equation but in polar term. Cosine and sine term polar. So here G and B represent conductance and susceptances. So this is how active power situation. Similarly, if I take the cosine to sine operation, sinusoid, then it becomes imaginary part of that is Vi summation J1 to N Yij as usual, Vj. Now you can see here sine. Cos got replaced as sinusoidal. Minus of theta ij, everything is same. Exactly the equation what I have here. Cos is replaced by sinusoid. That will be an equation here. Vi summation Yij Vj sine of minus outside the bracket, but sine minus of theta is minus sine theta. Hence this minus sign appears at the entrance of the basic equation. You can see Qi equal to minus summation J1 to N magnitude Vi, Vj, Yij sine of same term theta ij minus delta I plus delta j for all 1 to N. This is how this equation is exactly same as the equation what I am pointing right now. This is summation J1 to N Vi Vj Gij sin delta Ij minus Bij cosine delta Ij. This equation is in complex rectangular form. This equation is in complex polar form. Both are one and the same. So these two equations serve as basic load flow equations. Among the four quantities P, Q, V, delta or theta, these are the two basic equations. Repeatedly we need to solve them. Okay? Therefore, these two must be considered as basic power flow equations. Hence, if I understand these basic equations, what are those two left? Voltages, angle theta or angle delta or theta left off. So those two I need to consider. You may have a question. Obtain basic power flow equations. Then you need to derive this format, either in rectangular format or in polar format. For a n bus system, we have from the fundamental, we have these equations, and it could get convinced to this way, and PQ, PI and QI are like this, or they are also in this format like that. Then once I have these forms available, because these references are taken from text 1 as well as references You will find these things very similar in textbook also. And I'll be sharing these PowerPoint slides with you so that there will not be any confusion what I am referring, what you are going to get one and the same. So there will not be any worry. Once we know two basic power flow equations, Pi, Qi, my next task starts. Understanding some more prerequisites. Among the four quantities P, Q, V, delta, which I am speaking, depending upon that, the study of given power system changes. As we know, power system is an heterogeneous interconnection of generator, transmission line, transformer, switchgear, etc. The classification of individual buses should go because I have to solve for the unknown. Among the P, Q, V, delta, I have to find out two. Out of the four, two will be given to you, known to you, two will be unknown to you. Pertaining to the type of consideration, if it is a generator bus, which of the four are known to you, rest two you have to find out what method you should apply. For a slack or reference bus in the system, which of the four are known to you, rest how you need to calculate. If it is a load bus, if it is a voltage controlled compensating bus, what are those out of the four known to you, rest how you need to calculate. Then we need to understand. For that, the best understanding is classification of buses for load flow study. This could be one general question every time. Explain and obtain or explain how buses are classified for the load flow study in the power system. In the power system, buses are classified into four types. Some book classify as 3, some book explicitly classify it as 4. No matter, 3 or 4, let us see one by one. The buses are classified into 4 as per the presentation which I have prepared over here. The first type of classification is slack bus or reference bus of the system. What is the need of this? What are the four quantities which we are trying to discuss, among which two are known, which two are not known, we need to understand. Slack bus of a given power system is a reference bus. Because when you want to start a nodal analysis of a particular power system problem to find out the unknown voltages, which we call as a nodal variable, you need to have one reference datum, then only with respect to datum, other measurements, calculation stand valid. Hence, reference is required. In that purview, slack bus or a reference bus, some book refer swing bus, nothing but a reference bus in the power system which is assumed to have enormous active power and reactive power pumping ability. At that bus, voltage and angle V and angle theta or delta are known. Among the four quantities, P, Q, V, delta or theta, P and Q are unknown, assumed to be enormous in capacity, infinite. The two known quantities are voltage magnitude and angle of that, must be known to me. Then what must be the slack bus? Slack bus is a generator. Among the generators possible in the power system, usually biggest capacity generator is considered as a reference bus. Why it is considered biggest only? Because it should possess very large P and Q ability, and it should be able to maintain terminal voltage V constant and angle V constant. To keep V and delta constant, it should have a possible ability to pump active and reactive power to the grid. Hence, among the four quantities P, Q, V, delta, V and delta at slack bus are known. P and Q we have to find out. That's our task of load flow study. Now coming to the mathematical preliminary. Why slack bus concept has come into picture? Is there any real-time slack bus in the power system? Definitely, in the real-time power system, what the interconnected, integrated power system we have, there is no slack bus at all. Slack bus is a mathematical requirement to solve differential equations. The integration of these resources into the power system and transforming the relationship into mathematical term, it gets represented as a differential equation. To solve those differential equations, we need to have some initial conditions. Those initial conditions are mathematical requirement to solve the problem. So those initial conditions are electrically transformed as the representation as a slack bus among the four unknowns at that location to be known, voltage and angle, rest to be floating, to whom I have to find out. Hence, this is the mathematical prerequisite of numerical solution. In real time, there is no generator which is put with the title slack bus alone. They are generators only. This is just for the mathematical proof. Slack bus is referred, which stand as reference to every measurement what one would take on that power system. Hence, for the reference viewpoint, one of the generators is pulled down as a slack bus. That's all. It's a generator only. And it is supposed to have V and angle theta constant and active and reactive power ability tremendous and infinite. If I characterize these things, V and delta are the two known quantities at slack bus. P and Q are the two unknown quantities at slack bus. One need to find out by the load flow study procedure. That's all at the slack bus. Then moves the next bus, PV node or a PV bus. As the name says, PV, active power voltage. PV refers to active power voltage. So this refers to a generator bus only. What is a PV bus? PV bus is a station in which you have number of generators connected to the grid to pump the power into the national grid. So there may be any number of generators. Suppose there are 10 generators. All the generators are driven by some resource and they are generating and pumping power to the grid. Then those generators are supposed to have, out of the four possibilities, P, Q, V, delta, 2, which is its capacity P, active power delivery capacity must be known to us. And at what voltage it is going to work or inject the power, voltage must be known. PV, hence we say PV bus means generator bus, which is having two known quantities. P is known, its capacity is known. Voltage is known, at what voltage it should work. What are unknown then? Reactive power Q and phase angle delta or power factor angle delta are the two unknowns. Therefore, load flow study at PV bus refers to understanding the known things. The known things are capacity limitation of a generator P and terminal consideration, what it should sustain, what it should maintain V. Remaining are the one to calculate, which are unknown, to find out the reactive power ability of the machine and its phase angle associated as a task of load flow computation at PV bus. So I characterize again, PV bus is a generator bus. At that bus, P and V are known to us, Q and delta are unknown to us. Finding out of those Q and delta is a load flow study at PV bus. That's enough. Next, moving to another category, PQ nodes or PQ buses. As the name says, PQ. What is P? Active power. What is Q? Reactive power. Where do you find these two quantities mentioned? Yes, exactly at a load. At a load, we have so much of megawatt and so much of megavolt ampere load. It means to say, load bus is also known as PQ bus. At that bus, active power and reactive power demands are mentioned. But the remaining two quantities are what? P, Q, V, delta. Voltage and angles are not mentioned, not known. Finding out of those two is the work at load bus. Among the four, the unknowns are V and delta. So finding out of V and delta or V and theta is the process of load flow study pertaining to load bus. Therefore, we must be very careful. PQ, when I pronounce PQ bus, PQ are known to me. The remaining which unknowns are V and delta. I have to find out. The procedure followed, technique adopted, nothing but study of load flow at load bus. The next classification works out as voltage controlled bus. Can you see that? I have used some other presentation from the references. Voltage controlled bus. What is this voltage controlled bus? Think that in a power system we have generator, we have transmission mechanism, and we have load. As long as I am able to produce megawatt and megawatt ampere reactive and pump to the grid and meet the end user satisfaction, certainly good, able to meet the requirement, my system will be in a balanced condition, perfectly operating. Suppose the reactive power demand is increasing. I would otherwise say you are not able to maintain the voltage profile of the load side constant. The load bus should have a certain voltage, 1 pu, say 440 volt, 765 kV, something like that. Some voltage I use as a permit, 1 pu is your requirement. If you are not able to maintain 1 pu voltage at the load side and meeting the P and Q demand, it is falling down. Voltage is falling down gradually, floating, flickering. It's called as instability at that time. Why that voltage is not being maintained constant? It's because the reactive power demand in the system is not addressed properly. It means to say there might be a deficiency of reactive power generation in the system. Because of deficiency of reactive power, the system voltage at the particular bus is not being held constant. Then what you get from this? You need to maintain the voltage constant. It's a requirement. All the electrical equipments and components are supposed to perform fine, excellent duty, provided they work at specified working voltage range. Any voltage range going beyond that, definitely that equipment is not going to perform well. It's going to malfunction. Suppose whose data you are referring for any decision taking activity, your decision may go wrong. Your errors on whose correction into the system may protrude wrongly. System may go adverse. In that regard, voltage is a serious matter. I must maintain voltage to the specified value to the good extent. Then how do you control the voltage? The controlling up of voltage is because of reactive power deficiency only. Then you must inject artificially a reactive power to the certain point of a power system. Maybe you are trying to install capacitor bank. You are trying to use power factor compensating devices like a fact controller, flexible AC transmission mechanism devices. So those devices will add or remove capacitor, inductor in an appropriate manner so that required adequate reactive power need and necessities fulfilled by that substitution at location. That kind of controlling position, a terminal where you have reactive power banks are maintained, switching operation of those things will make required reactive power lag, deficiency fulfilled. Then we call that bus as voltage controlled bus because that is trying to retain the working voltage constant by injecting more and more reactive power or withdrawing reactive power if required. In that regard, like a generator bus, the purpose is to generate and pump. Load bus, simply draw the power. Slack bus, meet P and Q requirements, keeping the voltage and angle constant. The voltage control bus is targeted or identified with the activity. It should try to maintain the terminal voltage constant. By providing necessary reactive power, supplements the system. Then this is called as voltage controlled bus. What may be there in that? There may be a synchronous generator. There may be a synchronous motor in that position. There may be a capacitor bank or reactor which will get switched appropriately to see to it system reactive power need and necessities are addressed. It may be power factor. If I view it in a power factor term, lagging power factor may be the reason with which highly reactance is noticed. Because of it, you have to correct the reactance. You are correcting by compensating it by capacitor or making it over-excited, under-excited synchronous machine. So-called compensation is adopted at that bus or at that location that we considered as voltage controlled bus. The prime task of that bus is to see to that suitable reactive power is managed such that voltage is maintained at the constant. For that, a small example is taken there. Consider a bus K, wherein at that bus, a voltage controlled bus PIK made injection of active power at certain voltage Vk, and QI max be the maximum reactive power, QI minimum be the reactive power minimum. Then we know that QIK is nothing but net situation of reactive power at bus K. I am just terming K be the voltage controlled bus, PIK refers to active power injection there, QIK refers to reactive power injection over there. And when I say reactive power injection, what is the minimum injection? What is the maximum injection? I have limits called as QI max, QI min. Then I know. We will not worry about that AK. We will come to the next line. We know the current at bus K, like your II. In the previous slide we have seen current at ith bus we have seen. Similarly, current at bus K, IK is equal to product of admittance YKM with VM, where M is your incremental operator. M equal to 1 to N summation. So these terms, nothing but one of the equation from the matrix I bus equal to Y bus into V bus. From that, I took ith row in the previous interaction. Now I am taking kth row number K of current I am taking out. This represents me the current injected by the voltage controlled bus to the system, which nothing but at that bus what I am injecting active power PIK, reactive power JIK. You may ask why IK is referred here. No, it's just the indicator. PK, QK I can refer because this author has referred as P injection, PI, active power injection at the bus K, QI, reactive power injection at K. Hence I took it as study material for my presentation. Therefore, PK plus JQK is the complex power situation at the voltage controlled bus K, which is equal to, look at the RHS side, VK, IK conjugate, like VI conjugate I referred. What is VI conjugate? It is a complex power composed of active and reactive power, which is witnessed you. PIK is active power, JQIK is the reactive power, which is the separation which we did. Otherwise, VI conjugate should say is a complex power. Now, suppose if I have bus number I and J connected by an element Yij, you can see that denoting Yij as magnitude Yij and angle theta Ij for element between bus I and J. Let us assume bus I is having Vi voltage and delta I as an angle. You can see arbitrarily book to book various nomenclatures are mentioned. Vi, Vk, Vp, Vq, like that. You will be able to understand these notations, preliminaries we call them as. Easily you must grab first, you must try to reveal why it is used. Then you will be able to grab the content, what is being actually projected. So, Yij refers to an element which is imagined between bus I and J, having a magnitude of the admittance Yij and angle possible from that is theta Ij. Similarly, Vi being voltage magnitude, which I don't know, but I can give it as a preliminary Vi and angle delta I. Then I represent the active and reactive power injections done by voltage controlled bus can be given as Pi plus JQIK equal to, look into the same equation, Vi conjugate is referred. When Vi conjugate is referred, Vk delta K, like Vi delta I, Vk delta K. Summation, M equal to 1 to N, all the products, Ykm, Vm. What is Vm? Vm is a bus voltage. And we have angle of that is delta M. Delta M minus, and Ykm is the admittance, which is theta Km minus, because it is a conjugate of the current. When I take a conjugate, Ykm will become a conjugate, Vm become a conjugate, the angle gets negative. Hence it is theta Km is negative and delta M is negative inside the angle bracket. When I take the product, Let's see the simplification. It became QIK. Reactive power injected at voltage controlled bus QIK becomes magnitude Vk, sum of all the products M1 to N, such Vm, Ykm. Can you see here? Sinusoid is referred. What the sinusoid represents? Reactive term of the product. Previous slide we have referred. What is Pi, Qi in the basic load flow equation? When cosine comes, active power term. Sinusoid appears, the reactive term. You are working only on the reactive term, imaginary part of the above expression, which becomes sinusoidal part of the delta K minus delta M minus delta Km. This refer as injected reactive power at the voltage control bus to maintain Vk constant, which should be checked whether Vk is able to be within the range. Is the QIK within the QI max or QI mean? That's the task of voltage control bus. Hence, there are 4 buses: slack bus, PV bus, PQ bus, and voltage controlled buses in the power system for the load flow study worked out. Why it is done? Why classification is being done? Because among the 4 quantities P, Q, V, and delta, 2 of such quantities will be known to us. 2 of remaining will not be known to us. Finding out of those 2 unknown is the task of load flow. Hence, to calculate those unknowns specific to a type of classification, we should have mathematical work for that. Hence, it is being classified and worked out. Now, I summarize this. Among the buses, slack bus, specified things are voltage magnitude and phase angle. V and delta is known to me. What should be computed? Real and reactive power to be computed. P and Q should be computed at the end of the calculation. At generator bus or voltage control bus, whatever is that, it's the generator only. So at generator bus, magnitude of bus voltage and real power is given. Because P and V are given. Similarly, voltage angle and reactive power, delta and Q, you need to calculate. Therefore, at the generator bus, PV is known and Q delta is unknown. Calculation of Q and delta at load generator bus is the load flow activity. Similarly, with the voltage control bus. Voltage control bus, you need to check what is that reactive power you are injecting, what is that phase angle you have to calculate. Now, I am witnessing you here. Voltage control bus, PV bus are put in the same block, nothing but voltage control bus nothing but trying to maintain the voltage constant by substituting to the system or reactive power. Nothing but injection of reactive power. So therefore, I should be calculating those things. At load bus nothing but power is drawn out of the particular terminal where active power, reactive power demands are mentioned. You can see here. Real and reactive powers are mentioned. Magnitude of voltage and angles are unknown. P and Q are known. V and delta are unknown to you. Hence, calculation of these things is nothing but load flow study. So, I could just summarize you classification of buses for load flow and known things at load flow individual buses, unknown things to be calculated at each buses we got to know. Now, with this primitive knowledge, if I move, what are the different constraints? Apart from this having understood, are there any constraints in the power system which we need to consider? Limitation, condition? Yes, there are some more considerations one would know before performing load flow study. We call them as constraints in load flow study. Explain, list the constraints in load flow study would be a question for you. To explain and to present, you must know what are all those things. Let us say first one. The first constraint is voltage magnitude Vi. At any bus I must satisfy the inequality limit. What do you mean by this? In the power system, all the equipment, generator, transformer, transmission line, measuring device or a controlling device are hooked to the power supply, taking power from the supply and trying to exhibit their performance for the intended duty. They are supposed to work effectively when their working voltage is normal. When the working voltage is abnormal, below the expected or beyond the expected, out of range, definitely instrument is not only going to get damaged, it is going to damage the next things what it is being used for. Therefore, every equipment in the power system is supposed to work very effectively with the specific magnitude of voltage specified as a range. That's called as VI should be within minimum VI and VI max. This is called inequality constraint. Any voltage at bus number 1, it should be within this and within this. The range must be mentioned. So 440 plus or minus 5%. What is the meaning of 5%? It is a permissible change from working voltage to the left side of the value to the right side of the value, lower side, upper side. That's called as VI min, VI max. Within these boundaries, the working voltage must be there. That's the meaning called as VI should be within VI min and VI max. This is called as voltage constraint. An example has been given, 5 to 10% if I say a voltage, it should be maintained. So what is the indication if it go beyond? If it go below V min, beyond V max, definitely system is going to suffer voltage instability and collapses, or the problems associated with that load rejection. Why do voltage will rise suddenly? Suddenly load is removed, voltage will shoot up. Why do voltage fall immediately to a very low value? Maybe a dead short or maybe very heavy load directly. Anything may be a reason. So this is challenge. So that if you apply voltage magnitude as a constraint in the system, every bus in the system should adhere to the constraint that working voltage of that bus must be within the specific limit plus or minus mentioned. It is for its normal expected operation. It must be considered. This is one of the important considerations. If you are not able to maintain this voltage constant within this range, what is the indication? There is an acute shortage of reactive power in the system because reactive power delivery is insufficient, or there is no generation of reactive power as required, because of which voltage is violated. So therefore, we have one important characteristic. If reactive power balance is not there, voltage flicker, voltage oscillation starts. If frequency start oscillating, it indicates that active power delivery is insufficient. So frequency to active power and voltage to reactive power, we have a connectivity. This is an indicator, like a health monitoring of the power system. Next one. The second constraint is angular displacement between the vector of a voltage 1, voltage 2. We have seen delta I, we have seen delta J earlier in the discussion. The deltas are nothing but angles associated with the vectors V1, V2, V3, V4, V5 in the system. Suppose between any two voltages of two buses, V1, V2 if you consider, delta 1, delta 2, angular maximum permissible change, delta 1 minus delta 2, angular difference between the vector 1's angle, delta 1 and the delta 2 of the second shall not cross the maximum permissible value for the stability consideration. Power system need to be stable. Stability is an ability of a system to be in practice or in service even after experiencing major or minor disturbances. So that higher excursions in the power angle should not be allowed, because system may lose the synchronism. In that perspective, maximum angular displacement between any two voltage angles, delta I minus delta K, permissible absolute value should be less than the maximum given in the system consideration. So suppose this is 2 degrees, difference should not go beyond 2 degrees. That's the meaning of that. It means if it go beyond, you have measured it, you have understood by simulation. If it crosses the limit, system is going to become disturbed and oscillate further to have further disconnections or defaults. Therefore, certain angle is called as maximum angular variation between the phase angles of the vector I should be within the inequality constraint. This must be seen carefully. How do you do all these things? You must have a computer program which keep on tracking these changes, make the evaluation and project you as a message in the SCADA, supervisory control and data access system. So you have to have measurement of data, telemetering of data to the control center, measurement and presenting you in the form of meaningful text. So this must be an instrumentation part of the power system. It must be there, without which it's just a dump. Therefore, this is another constraint. Maximum variation in the angles of the voltage vector shall not go beyond the maximum permissible range of the system. If it goes, it is going to cause stability fault. Next one is owing to the physical limitations. As we know, the power, active power, reactive power limits. Suppose you have a generator, and generator we say PV bus. P is mentioned, V is mentioned. It cannot generate beyond a certain megawatt which is designed for. It's called a P constraint. It cannot inject more than a Q which is permitted for that generator or possible by that generator. We call them as the physical limitations of a generator to generate more and more power beyond a certain P specified and Q specified. So hence we should say every generator should be working well within the range PGI. PG means generation of active power at any bus I should be within the min and max limits. It should not be challenged. Produce more than what the maximum capacity, produce below a certain manufacturer specification which is not economic. In that regard, PGI, active power limitation, is a constraint on the power system. Similarly, QGI, reactive power injection by the generator, shall not be questioned beyond this limit. It has the ability, maximum, QGI is the limit. Beyond that limit, it cannot deliver. You cannot demand. If it demands, it's going to suffer. And it cannot go below a certain minimum because it is infeasible state of production. In that way, physical constraint of active power, reactive power need to be seen where you are not going to load beyond them. So this is another constraint one would see. The next is conservation of complex power. What do you mean by this conservation of complex power? When I say active and reactive power separate, what are the generation you are taking from generator 1, generator 2, generator 3? Nothing but sum of all the active power production, summation of PGI, I being 1 to n. Sum of all the production from different generators should be equal to sum of all the demands, various load 1, load 2, load 3, add them. That's called demand. Plus the loss in the system, PL, active power loss. So this is called as the P balance. P balance must be met. If you are not meeting the demand and loss by the generation, your system will never be in balance, and the loss or lag in P indicates frequency oscillation. Frequency will not be stable. Therefore, you should have active power balance in the system. By this way, net generation must be equal to net demand and loss. You have to work out such that generation meets this constraint. Similarly, reactive power. As a system is highly inductive, transmission lines are inductive, transformer, loads, induction machine, all the real-time loads are, unless specified, they are inductive. Therefore, they draw reactive power for the system. If you are not able to meet the reactive power requirements of those equipment, definitely system voltage cannot be maintained at a specified voltage. Therefore, reactive power balance is also very important like active power balance. Net injection of reactive power from the system perspective, QG1, QG2, QG3, by generator, by compensating device, whatever is that, entire reactive power injection at least is equal to demand of reactive power and loss of reactive power. If this balance is maintained, system is in stable operation. Therefore, these are the few constraints which one need to see to that those respective constraints will challenge you when you go out of box limitation. If they are maintained well within the range, then system will be in place, system will be appropriate to work with your requirement. It can cope up to a demand what you find. So this is one of the important questions you can see. Some more points also you can find in the books also. So this is how constraints are put into. Now moving to this, I just speak and stop. The Gauss-Seidel method. There were four important points, P, Q, V and angle delta. Among those, two are known, two are unknown from respective discussion just we had. Then how those unknowns are addressed? How that network equations are formulated from the solution viewpoint? I said the integration of such several components into power system and finding out those unknowns become a very non-linear representation of the relationship. Those non-linear equations need to be solved numerically. To solve them numerically, we prefer either Gauss-Seidel method or numerical Newton-Raphson method to work with. Therefore, when you work with the numerical method, you need to have relationship fulfilled first. Obtain an expression, what you find to, what exactly you want to apply. Therefore, in that view, Gauss-Seidel is the method comes to our first approach. Very simple numerical solution method, iterative process. It uses successive estimates or successive approximations, and it is repeatedly used till the particular solution becomes acceptable within the range. In that way, it is an iterative process of stepwise correction to the unknown. So, considering a system, suppose let us consider a power system without any generator buses. Let us say a particular bus is having a complex power. A complex power at bus K, any bus K, Vk Ik conjugate, Vi conjugate concept can be put as Vi conjugate refers to complex power. That complex power can be represented as P injection plus J reactive injection, called as Pk Qk, nothing but active power at K, reactive power at K, nothing but Vi conjugate concept. For all the buses in the system of n bus system, except the slack bus. See now, the work starts distinguished. What is slack bus? Slack bus is called as a reference bus. Reference bus are datum bus at which V and delta are mentioned and P and Q you need to do. Now, whenever load flow process starts, slack bus related calculation you are not supposed to perform from the beginning. At the end of the convergence of your algorithm or process, the first work is to look for that. Therefore, we are not going to consider slack bus from the beginning. Hence, we can say complex power at any bus other than slack bus is written as Vk Ik conjugate as Pik plus Jqik for all k equal to 1 to n and except F stand here as slack bus, which is represented as, you can see here, Vk Ik conjugate equal to Pik plus Jik, previous equation. Then this equation is, just look into this, take a conjugate of this again, Vk Ik conjugate, take a conjugate at left side, conjugate at RHS side. You will find the next equation, which is conjugate of this expression is here. This conjugate of conjugate becomes Ik. Vk becomes Vk conjugate now. This side plus J becomes minus J. Now, why you have done it? This is done to understand what is the current in this expression. Current at bus K is active power injection, reactive power injection, and current with voltage relation. We need to represent. So, take this Ik as a heading of the equation. Ik equal to Pik minus Jqik over Vk conjugate. Now, you got to know at any bus K, current is active power minus reactive power divided by voltage of that bus conjugate. If I take this ratio, that represents bus current of that K. It may be II equal to Pi minus Jqi divided by Vi conjugate. Any bus which you consider K in the position, this stands as a bus current expression. Now, in the earlier slide, we have used II, Ik. How we got it? From this bus. Several values of bus current 1, 2, 3, 4, 5, n in the first column is equal to matrix Y bus, Y1, 1, 2, 2, n on the diagonal, off diagonal into voltages. From this, 1, 2, 3, 4 in the left side, somewhere K is there, Ik. This current is somewhere one of the components here. I1, I2, I3, Ik, In. Ik, if I split and write only one equation from this, expand this only for Ik. How it looks like? It looks like this. Ik equal to, when I take this matrix, when I take this, look into this, how I do it? Suppose I1 I want. What is I1 equal to? I1 equal to Y11 V1 plus Y12 V2, Y13 V3, Y1n, Vn. Like first row, if I split and expand, I'll have expression. Like that, I want to take expression for Ik. Somewhere in the line, down the line, Ik is visible, which is equal to Yk1 V1, Yk2 V2, Yk3 V3. Like that, expression comes. Can you see here? Yk1 V1, Yk2 V2, so called Ykk Vk, last term is Ykn. This is to say expression obtained from compact form of matrix. At LHS we have situation active power, reactive power difference divided by voltage if I take that become a current. I am going to equate this difference and ratio with the standard expression obtained from this matrix. How is that? You can see here. Ik becomes expression which if I visualize the one term here, can you see one term here, k, double subscript kk. This I write separately. Can you see here? Ykk Vk plus remaining term again I put as a mathematical product and sum of them as a summation block. I made Ykk Vk exclusive inside this sum of product. You can see here Ykk Vk outside plus summation m 1 to n not equal to k. Wherever there is a 1 is there, 2 is there, 3 is there, n capital is there. That I am representing as small m stand 1 to n, but not equal to k because this term is personally done outside. So current Ik equal to Ykk Vk and rest all are put inside this summation block. M equal to 1 to n, Ykm Vm m not equal to k. Now I compare this equation of current Ik with the previous equation Ik. This equation is equated with this equation. Can you see here? I am equating them, combining them. What I get here? Unknown. For a given power system at voltage bus, voltage is my unknown. Likewise, some unknown I need to solve. This equation needs to be solved by Gauss-Seidel technique. I am trying to use the power system of n bus. Voltages are unknown to me. Those voltages I am trying to relate and trying to find out. From this, let us take Vk as heading of equation. Rest all you transfer RHS side. I will have Pk minus Qk divided by Vk conjugate minus this summation block on a right hand side. Can you see here? Minus summation m1 to n not equal to k, Ykm Vm. And this Ykk is nothing but divide RHS by Ykk. It is put as 1 divided by Ykk and in a bracket Pik minus Qik over Vk conjugate minus summation block. This is the standard equation Vk, voltage magnitude of a bus K, where K stands 1 to any number other than lakh bus. This we formulated as another equation to solve it by Gauss-Seidel technique. So I stop here only because next step is to how to solve this. We have to take iterative process wherein Vk is your unknown. Vk is your unknown. Unknown is at the LHS side. Unknown is at the right hand side. Vk conjugate here. Now you cannot solve this equation. You require a situation to solve by numerical substitution. Hence, Gauss-Seidel technique is used here. It is going to witness you. Vk is your unknown. You want to calculate the voltage of a kth bus. As well, Vk conjugate is here. And so many Vms are here without k. Unknown 1, 2, 3, 4 voltages are there. How do you solve this equation? So to solve this, we have to use numerical approach, which is Gauss-Seidel approach is preferred. So therefore, I stop at this point. In the next class, we go ahead with a further interaction. Okay, this is the point of devising ourselves the need of Gauss-Seidel technique to solve these complex non-linear equations. We stop at this point. Okay.